I'm James Lee. I am a software engineer on the project. I'm leading the software development for the rover software. I focus on its vision system, the stereo cameras, how it interprets the data that comes in from these sensors, and then how it utilizes that data to act. First mission to win the X Prize is going to the equator to scope out Apollo 11. We tested a couple of sites near campus that have features analogous to the lunar terrain. One of them is Robot City, that's historically been the testing grounds for FRC robots. Because there's that delay in telecom between Earth and the Moon, it's impractical to drive with, say, a joystick or like a game controller or something. So the way that we're planning on driving is using supervised autonomy. Instead of telling it to go forward for as long as you hold down like the joystick, you give it an absolute waypoint that it drives to by itself using software on the rover. It detects obstacles, it figures out where it is with respect to them, and then it drives to it in a path that's optimal for obstacle avoidance and power collection from the sun. You have two stereo cameras mounted some set distance apart, and if you find the same object, the same feature in both the image from the left camera and the image from the right camera, you can triangulate to find how far that feature is from the center of your stereo rig, or from the center of the image plane of your left camera, for instance. Having a featureless landscape is actually an asset, because that means there are fewer obstacles that we have to avoid. If you see a boulder, say, far off in the distance, the further away it is, the smaller the difference in pixels the boulder will be in your two stereo images. So you can use that to calculate to some degree of certainty the distance between you and this obstacle. Matching those features across time step, you can also ascertain how far you've moved in that time and how fast you moved in that time. In software, the challenge is primarily avionics. You have slower computers than what you're used to on Earth, and because of that, you have to find smart ways to get around processing power blockades. We've got great backing from Carnegie Mellon, especially in the areas of software and electronics. We've got Red Whittaker. He's bold. If anyone's going to get to the moon, it's him. He's the kind of person who will just do something unreasonable, pick a goal that's way out there, and follow up on that and eventually succeed. Well, you keep the same hours as your boss. So you end up working 12, 13 hours a day. You're driven because what you're working on is real cool. You're sending something to the moon. And you're like a 20-something-year-old college kid. It's something special. It's somewhat overwhelming. It's you wake up and you don't really believe that you're still, like, it sort of takes a moment for you to realize. I guess you don't realize that you're going to the moon until you actually get there. It's just it's too much to comprehend.